Algebra 1, Lesson 41, Finding Rates of Change and Slope. Our new concepts today are all about a rate of change. A rate of change is a ratio that compares the change in one quantity with the change in another. For example, the speed of a car is a rate of change that compares the distance in the time traveled. Let's take a look at the exploration to see this working out. Analyze the graph. Arvand leaves his house and jogs to Corey's house. Later they walk to a local pizza shop. The graph shows the distance Arvand traveled between the time he left home and when he arrived at the pizza shop. Letter A. When was Arvand traveling the fastest? Well, because speed is a relationship between distance and time, we'd say that the steeper the line here would be, the greater the speed, because the distance is increasing as the time is increasing. So he jogged initially to get to Corey's house. Later they walked to the pizza place. It's probably when he's jogging during this rate of change. His distance is increasing as time's going, but it's increasing at a higher rate than it is when they're walking at the second portion. Letter B. How long was Arvind at Corey's house? And how can you tell? Well, here at the 5-minute mark, he gets there, and they don't leave until about the 12, 14, 15-minute mark. So from 15 to 5, he was there for 10 minutes, in which his distance isn't moving. That means he stopped. He's at that one location for 10 minutes. Letter C, compare the graph during the times Arvind was jogging to Corey's and when they were walking to the pizza shop. So in 5 minutes, he traveled 1 mile while jogging, and from 15 to looks like 22 and 7 minutes, they traveled half a mile while walking. So obviously they were running faster here. Arvind was running faster here while he was jogging than he was while he was walking. So this would have a greater rate of change during this process. Let's take a look at how you would go about calculating that rate of change by looking at a graph, a table, and then an equation to help us solve this. Example 1. Determine the rate of change from a graph. A car travels on a highway at a constant speed. The graph shows the relationship between the distance traveled and the time traveled. Find the rate of change. Basically, when we're finding the rate of change, we're finding the rate or the change that's happening in the two variables that are presented. In this case, we're going to write these out as a fraction in terms of distance and time. You can see here. We're going to find the change in the distance that occurred and the change in the time that occurred and compare those two in this fraction form. So it says choose 2 points on the graph and find the ratio of change in the distance to time. So initially, finding rate of change in a graph, you simply have to choose 2 points. From any 2 points, we can find how much has changed during the duration between those 2 points. So the 2 points that are chosen here are 1 at 60 and 2 and 120. So driving 1 hour, you go 60 miles, 2 hours, 120 miles, 60 miles per hour, right? So we set this up and we calculate the change in distance in the numerator and the change in time in the denominator. Notice that the change in distance is on our y-axis, that goes in the numerator, and the change in time on the x-axis goes in the denominator. So we would take 120 minus 60 and 2 minus 1, that's what they set up in this problem here, to find 60 miles per hour as the rate of change. Each hour that you're driving, you're going 60 more miles. Now, here's how you're finding it from a graph. Again, picking those 2 points, you subtract the y's from each other in the numerator and the x's from each other in the denominator. Notice how they stay in that same order. As 120 is subtracted from 60, because you subtract the larger number from the smaller number, so 2 is subtracted from 1. So 120 over 2 minus 60 over 1 to give you 60 miles per hour. In example 2, it says determine rate of change from a table. Here you have a set of data points or points that could be plotted on a graph. We're going to select 2 of those just like we did in example 1. A shop charges a fee for renting kayaks. What's the rate of change for the rental fees? So when you're renting something, a lot of times it's based on the hours that you're renting it. In this case, if you rent a kayak for 2 hours, it costs you $32.50, 4 hours, $60.50, 6 hours, and so on. So the solution here, notice that the cost increases the same amount every 2 hours. Choose 2 sets of values from the table and find the ratio of the change in the cost, change in time. So again, pick 2 points and then do your changes in the cost and the time categories. Here, the change in cost is going to be the subtraction of 60.5 minus 32.5. It goes up by $28 for every 2 hours. And then the hours is changing in increments of 2 as well, so you subtract those, 4 minus 2. You set it up as this rate of change fraction, in which you've got your y variables in the numerator, your x variables in the denominator, and you then subtract in those categories. 60.5 minus 32.5 is 28, 4 minus 2 is 2, 28 divided by 2 is $14. Every hour it costs you $14 more when you're renting something in this case. In both example 1 and example 2, our initial skill, pick a point, pick another point, and then set up this subtraction problem with the change in one of the two variables. Okay, so pick 2 points and set up this ratio in which you're subtracting the difference between those two sets of points. How do you find the slope of a line? Well, the slope of a line is what we call the rate of change. Here's just the mathematical term for it. The slope of a line is a rate of change is equal to the ratio of the vertical change, rise, to the horizontal change, run. Slope we often refer as rise over run. So why I told you before that the y-axis goes in the numerator, because that's y measures how far something's going up or down. That's the rise, x is the run here. So to find the slope of a line using 2 points, you're subtracting the y's, the rise, in the numerator, and the x's, the runs, in the numerator. Let's take a look at example 3. Determine slope from a graph. Find the slope of each line. In example 1 and example 2, it says pick 2 points. We pick those 2 points. Here it has 0.41 and 0, -1. Find the ratio of the rise to the run. So you'd say, how much does it go up versus how much does it go over to find the difference between these two? In this case, you went from 0 in terms of your x-axis over to 4, so the run is 4. The rise went from -1 up to 1, so you'd count 1, 2. So the rise, it went up 2 over 4. You set that up into your fraction. The rise went up 2. The run went over 4. 2 divided by 4 is equal to 1/2. In this graph here for letter B, you've got rise and run calculated by drawing this line out just like they did in example A. You're going to first calculate the rise, so your initial point was 1, 1, and then it went down, it looks like, to -8. So from 1 to -8, that's down 9. So that's why we have a -9 here. And then it went from 1 to +4. It's going to go over 3. So the rise is -9. The run is 3. You would reduce that fraction, -9 over 3, is -3. Notice as it's going up from left to right, that's a positive slope. As it's going down from left to right, that's a negative slope. And so we have a positive answer here and a negative answer here. A line with a positive slope rises from left to right. A line with a negative slope falls from left to right. There are 2 other cases to consider, and that's horizontal and vertical lines. The graph of an equation y equals c, where c is a constant, is a horizontal line. The slope of the horizontal line is 0. So in this example, we would say that y equals 2, because the line is always at 2. It's going to be a horizontal line. The graph of an equation for a vertical line is x equals c, where c is a constant, is a vertical line. So x equals, in this case, 3. You've got the line that's going right here that is vertical. So if it's y equals and it's a constant number, it's a horizontal line. If it's x equals and it's a constant number, it's a vertical line. How do you go about graphing those? Well, to find the slope of a horizontal line, you would again take 2 points and then do the subtraction of those 2 points. One of the equations that they're going to use here is described as the way in which you would find rise over run from 2 points, and that's where you take y2 minus y1. So you have your 2 sets of ordered pairs. One of these is considered x1 and y1, and the other is considered x2 and y2 because you've got your first points and your second points. You're going to take your second points and you're going to put those into the very first position, so it's y2 minus y1. So in this case, you're going to say 4 minus 4. So y1 is here, y2 is here, 4 minus 4, and that's written in the numerator. Then you're going to take 6 and 2 and you're going to subtract those as well. Because this one came first, it's the larger number, we're going to put that first. 6 minus 2 is 4, so you have 4 minus 4, and 6 minus 2 is 0 over 4. The slope of a horizontal line, this flat line, means it's not going up or down, it's completely flat, is going to be 0. Make sense? In letter B, it says find the slope of a vertical line. Well, slope is it going up or down, and vertical line looks like it's doing both, so what is our answer here? Again, the skill is to pick 2 points. So you're going to pick 2 and 8, 2 and 4, and you're going to set up your ratio y2 minus y1 divided by x2 minus x1. In this case, you've got 2 and 8 and 2 and 4. It looks like 2 and 4 are going to be our x1 and y1. 2 and 8 are going to be y2 and x2. So we're going to set this up to say what is 8 minus 4 and 2 minus 2. When you write that out, 8 minus 4 is 4, 2 minus 2 is 0. You've got 4 over 0. Wait, there's a 0 in the denominator. That cannot be. Therefore, this is undefined. There is no slope for a vertical line because it's not increasing or decreasing at a specific rate. It's going straight up and down. Therefore, there is no slope. The slope is undefined. Our application. Example 5. The graph and table show the relationship between the number of servings a salsa recipe makes and the ounces of black beans used to make this recipe. So there's two factors that we're going to be calculating here, and we're finding the rate of change between those. Here you've got servings and black beans. Use a table or graph to find the slope of the line. In both of these, you're going to use the same technique. Pick 2 points, so those points are already plotted for you, or pick 2 points on the table. Here you've got 18 and 45, 6 and 15. You're going to find the rate of change by doing your subtraction between those factors. So between 45 and 15, you would subtract. What's the difference between 45 and 15? It's 30. And the rate of change between the corresponding points, 18 and 6, is 12. Or in this case, they're using 2 different points. You'd maybe use the 4 and 10 and 6 and 15 here. That's what they did in your solution. But either way, you're going to get the same answer. If we did 45 and 18, 15 and 6, 45 minus 15 is 30. 18 minus 6 is 12. 30 over 12 is going to reduce down to 5 over 2. You use these 2 points. 15 minus 10 is 5. 6 minus 4 is 2. 5 halves is your slope. It goes up 5 over 2, up 5 over 2, up 5 over 2 as you're increasing the number of servings. You're going 5 more ounces of black beans every 2 servings. So here's our rate of change in terms of that application to that, finding that from a graph, or finding that from 2 points, or finding that from a table. Okay? Your lesson practice has you practicing using that rate of change, and your practice problems will introduce that to you in a number of problems as well. Go ahead and get those practice problems done. They are the ones that are circled for lesson 41. God's blessings.